All right, welcome to the next video here on the Chapter 9 Calculus practice test. And we're going to do some more integrals, improper integrals. And here we've got the integral from 0 to 4 of dr over 4 minus r. Like with the previous examples that we did in the other video, the just previous video, we're going to find our antiderivative first. So we have the integral of dr over 4 minus r square root of. And this integral looks to me like just a regular u substitution. So if u is equal to 4 minus r to the 1/2 power, then du is going to be equal to, actually thinking about this, we don't need to even do all of this. We can just say u is equal to 4 minus r. So if u is 4 minus r, then du is going to be negative dr, or to put it in a way that's going to be helpful, dr is going to be negative du. So this integral becomes, well, the dr becomes negative du, and this 4 minus r becomes u. Now we're going to turn this into a negative exponent so it's easier to take an integral. And this integral, well, if we add 1 to the power, negative 1/2 plus 1 is 1/2. And the reciprocal of 1/2 is, of course, 2 over 1. So this looks like negative 2 square root of 4 minus r plus constant for that antiderivative. And now we'll tackle the definite integrals. So if we're going to integrate from 0 to 4 of dr over root 4 minus r, the real problem happens at 4, because if I were to substitute 4 into this integrand, I would get 1 over 0, which is undefined. So we're going to replace that upper limit and use a limit as b approaches 4, technically from the left, of 0 to b, and that's going to be dr over root 4 minus r. Of course, we already know the antiderivative, so that makes this part of things easier. This is just a limit as b approaches 4 of negative 2 root 4 minus r from 0 to b. Next, we substitute. Substituting our upper and lower limits, we get negative 2 root 4 minus b plus 2 root 4 minus 0. And of course, substituting 4 here is not a problem anymore. So this is 2 root 4 minus 4 plus 2 root 4 minus 0. And this just gives me 2, which completes the problem. Now moving on to our next problem here, we've got the integral from 1 to infinity of dx over x squared plus 7x plus 12. And note that we have the integrals going from 1 to positive infinity. That positive infinity is probably going to be our problem spot. Let's try and find our antiderivative. So we've got the integral of dx over x plus 3 multiplied by x plus 4. I'm going to need a partial fraction decomposition here. So 1 over x plus 3, x plus 4, a over x plus 3, plus b over x plus 4. Putting everything to a common denominator, we get ourselves 1 multiplied by x plus 3a plus x plus 4b. Our first convenient x to substitute is x equals negative 4, which yields 1 equals negative 4 plus 3a plus negative 4 plus 4b. And that tells me that a is going to be equal to 1 negative. Our next convenient value is x equals negative 3. And when I substitute, I get 1 equals negative 3 plus 3a plus negative 3 plus 4b. And that tells me that b is equal to positive 1. Making my partial fraction decomposition negative 1 over x plus 3 plus 1 over x plus 4. Getting back to the integral then, the integral is going to be equal to the integral of, and we're going to use this first one, negative 1 over x plus 3 plus 1 over x plus 4 dx. And then using the natural log integration, this is going to be the negative natural log of x plus 3 plus the natural log of x plus 4 plus constant. And of course, that's going to be equal to the natural log of x plus 4 on top of x plus 3 plus constant. So there's my antiderivative. Now we just have to use that in the definite integral. Okay, our problem spot is at infinity, so we're going to have to replace the infinity in our integral with a dummy variable. So now we have a limit as b approaches infinity of the integral from 1 to b. And since we know the antiderivative, that makes this next step easier. Since I'm looking at values of x between 1 and positive infinity, there's nothing in that interval that's going to make my natural log negative. So I don't really need those absolute values anymore. Now I can substitute my values for b, or upper limit and lower limit. So we'll substitute our upper and lower limits. And the only thing where we have to use this limit as b approaches infinity is going to be this first term. So let's take this first term. I notice that b to the first power is the highest power. So I'll divide everything by b. And that's going to set up this new equation where I have the limit as b approaches infinity of 1 plus 3 over b over 1 plus 4 over b minus the natural log of 4/5. Now we know that anything that's left with a b in the denominator, that limit is going to be 0. I also noticed that I forgot the natural logs there. I got a little bit too far ahead of myself. But anyways, this is going to become the natural log of 1 over 1, which is just a natural log of 1. Well, the natural log of 1 is 0. So this is really negative natural log of 4 over 5, which is actually the same thing as a natural log of 5 over 4, which completes this problem. Now, the next problem we're going to look at, number 17 here, that's going to be x squared e to the negative x. And looking at this antiderivative, well, this is going to be something. U substitution is going to fail me here because the power over here of the x squared exceeds the power of e to the exponent for e. So, but this is actually a kind of a classic setup for a integral by parts. So we'll do that first. We've got x squared e to the negative x. Take some derivatives in integrals. Take another derivative in integral. And do yet another derivative in integral. Then we're going to assemble. With this antiderivative, we're going to, it looks like we can factor. I'm going to want to factor a negative because every term is negative here. And I'm also going to factor an e to the negative x. And then because I kind of know where this is going, I'm going to change that from negative e to the negative x to 1 over e to the x. Okay, so here's our antiderivative. Negative quantity x squared plus 2x plus 2 over e to the x, whole thing plus c. Let's move that over to the right side and take a look at the definite integral. I notice that the upper limit here is infinity, so I'm going to set up that the integral with the upper limit as a dummy variable. And now I'm going to use my antiderivative. And along the way, I kind of had a change of heart here. I'm going to go and rewrite this antiderivative as a sum of 3 addends, which is totally fine because we're talking about a fraction here, and we can separate the numerator out with the same denominator. In any case, At this point, it's a good time to start substituting our upper and lower limits. So let's go ahead and do that next. Okay, my first limit part here, we can definitely take the limit of each one of those addend separately. So let's do that. Of course, that second part of the substitution, when I substitute 0, I'm left with -2. And now there are 3 limits I need to deal with. This first limit over here, we'll start with this one, that is an indeterminate form. As b goes to infinity, b squared goes to infinity, and e to the b also goes to infinity. So we're okay to use L'Hopital's rule there. And then the same thing with this second limit. We've got 2b on top of e to the b, and as b goes to infinity, 2b goes to infinity, and e to the b also goes to infinity. So we are okay to use L'Hopital's rule there too. Now this next term, 2 over e to the b, the numerator is constant and e to the b grows without bound, which means that this limit is actually equal to 0. And then don't forget plus 2 at the end there. Let's take a look at what we have. We've got the limit as b approaches infinity of -2b over e to the b. Well, like before, 2b goes to infinity and e to the b also goes to infinity. So I can use L'Hopital's rule. For my next term, I've got the limit as b approaches infinity of 2 over e to the b. Now, just like over here, well, actually, we did this exact same limit over here. So 2 over e to the b, we know that that limit is 0, and the rest of it carries down. And now taking a look at the last instance here, in my yellow limit, I've got -2 over e to the b. I know that that limit is going to be 0, and bring the rest of it down. And putting it all together, the integral from 0 to infinity of x squared e to the -x dx, that's going to be equal to 2. And that brings us to the end of this set of questions for your Chapter 9 practice test. Good luck, and I'll see you on the next video.